Welcome to Educator.com. In today's lesson, we're going to discuss multiplying rational expressions. The procedure to multiply rational expressions is to multiply their numerators and multiply their denominators. So you handle this the same way you would handle multiplying regular fractions. So recall that a rational expression is simply a fraction that has polynomials in the numerator and denominator. For example, something fairly simple, 3 over x times x squared over 9. Well, I'm going to multiply the numerator and the denominator. So writing this in more of a standard form, I've got 3x squared divided by 9x. Now, to simplify that, I'm going to go ahead and cancel out the 3. That's going to give me a 1 here and a 3 here. And I can also cancel out the common factor of x. So that's going to give me x over 3. Slightly more complex set of expressions. If I had x over x plus 1, and I'm multiplying it by 2 over x plus 3, that would give me x times 2 over x plus 1, x plus 3. Or 2x over x plus 1, x plus 3. And you can leave that in factored form as it's shown. So again, all you need to do is multiply the numerators and the denominators. To make this easier, you should cancel common factors in the numerators and denominators before you multiply. That way, you're working with smaller numbers. For example, if you're given 9y over 10xy squared times x over 6, what you need to do is start canceling out and then multiply whatever's left over. For example, I have a common factor of 3. In the 9 and the 6. 3 goes into 9 3 times and into 6 twice. I also have a common factor of y. This y cancels out and the y squared becomes just y. I have a common factor of x. The x's cancel out entirely, and now I have something that is much easier to work with. What's left is just a 3, 10, and 2, so 10 times 2, and a y. Multiply that out, gives me 3 over 20y. Therefore, by canceling before multiplying, the multiplication is much easier because it's smaller numbers, variables that are raised to lower powers. If you're working with rational expressions that contain polynomials, factor the polynomials in the rational expressions first. Then cancel the common factors and multiply. Again, the purpose of this is to give you something simpler to work with. What you're doing here is really simplifying. And you're going to be multiplying then some expressions that are less complex and easier to work with. For example, if you're given x squared minus 9 over 4 and asked to multiply that by 2x over x squared plus 5x plus 9, I see that I'm working with some polynomials, so I'm going to go ahead and factor those. X squared minus 9 is the difference of two squares, so that's going to give me x plus 3 times x minus 3 over 4 times 2x. Here I have x, and since these are both positive here, I'm going to have x plus a term, and then another x plus a term. And factors of 9, what I need here are, actually this should have been a 6. Go ahead and make that a 6. X squared plus 5x plus 6, so that factors out much more easily. If I have 1 and 6, their product is 6, but they add up to 7. So let's try 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So x plus 3, x plus 5. Okay, so now I've factored these out, and I'm going to go ahead and start canceling my common factors. And I did have a common factor of x plus 3 that I canceled from the numerator and the denominator. Now I just need to multiply what's left, which is x minus 3 times 2x over 4 times x plus 5. I actually just noticed I have a common factor left of 2. So I'm going to get rid of that. And I also want to just rewrite this so that the x is out in front. And now I've multiplied it. And by doing that after I factored and canceled out my common factors, I had something that was a lot easier to multiply than the original expression. So this is my final answer, and I'm going to go ahead and leave it as it is in factored form. I don't need to multiply all this back out. Okay, my first example, I'm asked to multiply these two rational expressions. By simplifying first, multiplication is going to be a lot easier. So rewriting this so that I can start canceling things. Being careful that I rewrite it just as it's written above with all these exponents. Okay. Okay, I'm going to cancel out common factors in the numerator and in the denominator. So first, dealing with the numbers. Well, I'm looking at 24 and 16. Let's start with that. I have a common factor of 8. That gives me 3 here, and then 8 goes into 16 twice. I have another common factor between the 8 and the 2. A common factor of 2. The 2 cancels out, and I'm left with a 4 here. I have a common factor of 3. 3 and 9. 3 cancels out. Here I get 3. So I handled the numbers. Now I need to handle the variables. For x, I have x cubed and an x here, and in the bottom, in the denominator, I have an x. So I'm going to cancel these two x's. Now I'm going to look at what I have for y. I have y squared, I have a y, I have y squared, I have y squared. So the simplest way to handle this is just going to be to say, okay, I have y squared here, those cancel. Y squared here and a y here. This y cancels and leaves me with just a y here. Now my z's. I have a z up here. This z cubed is going to become z squared. W's. I have a w here and a w squared here. This cancels out. This becomes w. So let's look what I have left. In the numerator, I have a 4. I have x cubed. And I have a y left. Looking, everything else is canceled out. In the denominator, I see I have a 3. I have z squared. I have z to the third. And I have a w. So I need to finish multiplying now. A lot easier than multiplying all of this. Numerator's done. Denominator, I actually have 3 z to the 5th times w. So this is my expression now multiplied out. Simplify first, cancel out common factors, and then multiply. Okay, my second example, again, multiplication, and I have polynomials here. So I'm going to factor those out first, cancel out common factors, and then multiply. So factor, cancel, common factors. And then multiply. In order to factor, I see that I have a greatest common factor for this first binomial. So I'm going to pull out that 2 to get 2y plus 3. In the denominator, factor out a 3 to leave behind y minus 4. Up here, factor out 6. That leaves behind y minus 4. And in the denominator, if you factor out the common factor of 4 from each of these, you're going to end up with y plus 2. Okay, now that that's done, I've factored, I need to cancel out common factors. And what that's going to leave me with is, I'm going to cancel out this 2. This is going to become 2 down here. I've got a common factor of 3 in these two. That cancels. And that's going to leave me with the 2 here. So 2 and 2, that cancels. Or you may have just noticed that it's 2 times 6, which is 12, over 3 times 4, which is 12, and that all the numbers cancel. I've also got some common factors left over here. What I have is y minus 4 in the numerator and in the denominator. I've canceled, now I can multiply. And all I've got left on the top is y plus 3. In the bottom, it's y minus 2. So again, the key is to factor and cancel before you start multiplying. This third example is more complex, involves quite a bit of factoring. I've got binomials, I've got trinomials, so I'm going to get started, as always, factoring first, cancel common factors, and then multiply. Okay, starting out, factoring out the common factor of 2 from 4x minus 6. That's going to leave me with 2x minus 3. In the denominator, I have a common factor of 6, which is going to leave behind x plus 4. And you can always check these by multiplying back. Over here, before I start trying to deal with the whole trinomial, I'm going to pull out this common factor of 3. And that'll leave me with the leading coefficient of 1, which is much easier to factor. In the denominator, there's nothing I can pull out, so I'm left with, I'm going to have to factor out this expression as it is. Okay, over here on the left, this is already factored out as far as it can go, so I'm just going to rewrite it. Starting with the numerator, I see that I have a leading coefficient of 1, so I'm going to have x as the first term in both of these. I also see that I have a negative right here, and that tells me I'm going to have a positive and a negative as part of my two factors, the binomials. Okay, the thing I need to do is figure out what this middle term is by determining what the factors of 12 are. And those are 1 and 12, 2 and 6, and 3 and 4. And what I want are factors of 12. And when one is positive and the other is negative, they add up to 1. And I can see that I'm going to have to go for something close together like these. And since I want to end up with a positive here, I'm going to make the larger term the positive. So I'm going to try this, and I'm going to double check it. So the first terms, the product would be x squared. The outer terms would give me negative 3x. The inner terms would be negative 4x. I add that together, it's x. And then 4 times negative 3 is negative 12. So that is correctly factored. The bottom is definitely more complex because I have a 2 here. So I'm going to have 2x and x. Since this is also a negative, I'm going to have a positive and a negative. And I already have my factors of 12 here, and I want to end up with a 5x. And that's not a particularly large number, even though there's a 2 thrown in here that I'm going to have to multiply times. So again, I'm going to go for some of the smaller numbers, either this or this. So trying really just by trial and error, 3 and 4. If I tried 2x plus 3 times x minus 4, I'm going to end up with 2x squared. Okay, the outer terms, that's negative 8x. The inner terms, negative 3x. This is really what I'm interested in. That's negative 5x. That's not correct. So let's try it the other way around. Let's try 2x minus 3, x minus 4. Putting the 3 over here and making it negative. So let's just work with the outer and the inner to figure out this middle term. That's going to give me negative 8x actually that needs to be positive because I need to have one negative, one positive. So that's going to give me positive 8x, and then the inner is negative 3x. That's 5x. So again, all I did is I took the factors of 12, and when I'm working with a 2 here, I just need to do trial and error, try some different combinations until I find a combination where the middle term, so if I'm doing the first terms, I get 2x squared. The outer term is 8x. The inner term is negative 3x. The last term is going to be negative 12. So I know I have the first and last terms. Now, the outer terms plus the inner terms add up to 5x. So that does give me my correct middle term. So I know that the correct factorization is actually going to be 2x. I'm going to put this as a minus 3x plus 4. That's the correct factorization. Okay, so I finally factored. That was the hardest step. Now I'm going to cancel out common factors. And I can see here that I have a 2, and that has a common factor with 6. I'm going to be left with the 3. 3 and a 3, those cancel out. Or I could have just said, 2 times 3 is 6. 6 down here, common factors, and canceled everything. Okay, this 2x minus 3, common factor. X plus 4, common factor. And that's it. These two, no common factor. So after all that, I end up with x minus 3 divided by x plus 4. Factored first. That was the hardest step in this problem. Then cancel out common factors. And then multiply. And all I had left is x minus 3 divided by x plus 4. Again, another example where we're going to have to do a lot of factoring and simplifying before we multiply. Beginning with this trinomial. I'm going to have x, I have a negative here, so that tells me that I'm going to have a positive and then a negative sign. Factors of 18. Some possibilities are 1 and 18, 3 and 6, 2 and 9. And I want factors that are going to add up to 3x. These are too far apart. That's not going to happen. So that's not a possibility. The second one is 3 and 6. Well, if I wanted to add up to 3x and I made this positive and this negative, I would get a 3. So that's the correct factorization. I want x plus 6, x minus 3. And you can always check by multiplying out. X squared minus 3x, inner terms, 6x, that gives me 3x, minus 18. The denominator, the first step is going to be to factor out the common factor of 2. To get 2x squared minus 2x minus 8. Okay. Here I have a common factor of 4, and that's going to leave x squared minus 16, difference of 2 squares. Down here, I do not have a common factor between 2, 9, and 18, so I'm going to leave that as it is. Okay, this numerator I already took care of. Next, factor out right here. I have a negative and a negative. So since I have a negative here, it's going to be x plus something times x minus something. And what I'm looking for are factors of 8 that are going to add up to negative 2x. 1 and 8 are not going to add up to negative 2. So I tried 2 and 4. And if I make the 2 a positive and the 4 a negative, I'll get x squared, outer terms negative 4x, inner 2x. Negative 4x plus 2x is negative 2x. 2 times negative 4 is negative 8. So that's correctly factored. This one's easy because it's the difference of two squares, a squared minus b squared. So I know that this is simply going to be x plus 4 times x minus 4, bringing down that 4 that I factored out. This one's the most complex. I've got a 2x and an x, and I know I have a negative here, so one of these is positive, the other's negative. And I do have my factors of 18. 9x is the middle term. So I'm going to look for numbers that aren't too large because I will multiply one of those by 2. So if I use a big number like 18, I'm going to end up with something huge and it's never going to go down to 9. So just using trial and error, if I take 2x, let's try minus 3, and then let's try x plus 6. I get 2x squared is my first term, my outer term, 12x, inner term, negative 3x, last term, negative 18. These two do add up to 9x, so this is the correct factorization. So I'm going to write this as 2x minus 3, x plus 6. Okay. Factor first, then cancel. So I've got this all factored out, and I'm going to look for common factors. For the numbers, I've got a common factor of 2. 2 cancels out, 4 becomes 2. I also have a common factor of x plus 6. I have a common factor of x minus 4, and I'm looking through. That's it for common factors. Now multiply what remains. So I'm going to have 2 times x minus 3 times x plus 4. So multiplying the numerator. In the denominator, I have x plus 2 times 2x minus 3. Okay, so the first step was definitely the longest, factoring, factoring each one of these polynomials out as far as I could, then canceling out common factors, and finally multiplying what remains. So in today's lesson, we learned about multiplying rational expressions, and I will see you again soon for more lessons on rational expressions at educator.com.